Again, matrix, we are still on the revision of functions, which is in paper 1 of your question paper. So that is a sample of another question from a question paper again. So this information is given to us. The sketch below shows the graphs of f of x is equals to the logarithm with base 5 of x. So this is the graph of a logarithm. If we look at it, is this line that is going this one, that is f of x, and we are given another one, which is g of x equals 2 divided by x minus 1 plus 1. That is our hyperbolic function, and we are told that t and u are the x-intercepts, so that is t and u are the x-intercept of the graphs g and f respectively. So t is the x-intercept of g and u is the x-intercept of f. That's what respectively means. This line, so there is a line there, you can see it, a straight line y is equals to x passing through the origin, intersect the asymptotes at r, if you look at that, and the graph of g at v. So that is where the v is. Okay, let's check. This is question 4 still. So we are dealing with the question 4. And the question 4.1 says, write down the coordinates of u. Remember, folks, u, it is the asymptote that passes through the x-axis. So if you look at the information given, the graph or the equation which you have, that is g of x equals to 2 divided by x minus 1 plus 1. So if you want to find the asymptote that is passing through u, or that is on that line of u, you are going to use the x part or the denominator, which now it's going to give you x equals 1. So therefore, the coordinates of u, it's going to be 1 and 0. 0 is just because it's on the x-axis. Remember, the line x-axis is the line whereby y is always equals 0. Okay, that's 1 mark. It's pretty clear and straightforward. When we go to 4.2, they say write down the equations of the asymptotes of g. So they are repeating something here if you look at it. Remember, for you to realize u, you were looking at the asymptote of g. Now they are saying to you, write down the equation. In an equation form, therefore, your asymptotes will be y equals 1, and the other one is x equals 1. Look at this. The y equals 1 is your horizontal asymptote, and the x equals 1 is your vertical asymptote. And you have collected now another 2 marks, so it is straightforward and pretty clear to get. The 4.3, it says, determine the coordinate of t. Remember, they told us that t, it is the x-intercept of g at the beginning. So then it means that we are going to let y to be 0. So if you let your y to be 0, which is your g of x, you will have 0 equals 2 divided by x minus 1 plus 1, which will be a minus 1 equals 2 divided by x minus 1. Remember, the minus 1 happen when you subtract 1 in both sides of your equation. So if you say 0 minus 1, you'll get a minus 1. If we say a 1 minus 1, you'll get a 0. That's why on the right side you have 2 divided by x minus 1. Then you go on multiply both sides by x minus 1. So here what you have done is to subtract 1, subtract 1. Then you get to the statement, multiply by the x minus 1, multiply by the x minus 1. When you do that, you will end up on the right side with only 2, and on the left side you will multiply out to remove the brackets. So then you will have a negative x and plus 1. Now your negative x will be equals to 2 minus 1, because you are going to say minus 1 in both sides of your equation. So that is the second statement. After that, you will have a negative x equals 1. then you multiply or you divide both sides by a -1, then you remain with x equals a -1. And that is your x-intercept at t. But they say you must write it in the coordinate form because they say determine the coordinates. So you must write it in the coordinate form with -1 and 0. Remember, you said y is 0 at the beginning for you to end up with -1. So that's what you needed to have done, folks, and you get it right. It's simple, straightforward, and clear, and you get your 2 marks. Okay. Then we go to question 4.4. If you look at 4.4, they're saying write down the equation of h. Now, if you look here, you don't have the h, but they're saying the equation is of h. The reflection of f in the line y is equals to x. Remember, the equation of f is log base 5x, or log x with base 5. So you must find its reflection along the y is equals to x line. And remember, y is equals to x line is the line that makes an inverse to the graph. So what they're asking you here is to find the inverse of the graph of f, for which they did not really specify. They wanted you to remember or to be able to acknowledge that a reflection along line y equals x is the same as the inverse. So to do that, then we're just going to be writing our equations. So you interchange them. In other words, there you have f of x is equals to log with base 5 of x. Remember, your f of x is your y. So this can be rewritten as y is equals to log of x divided by log of 5. And then you interchange your x and y positions. When you interchange your x and y positions, you will therefore have y log 5 equals log x. And then y log 5 can be rewritten as log 5 to the exponent y. That is the same with, which will be equals to log of x. And now if you look at it, you have log y to the exponent of 5 in both sides, so you can change it. Then you have 5 to the y equals to x. And in this way, you need to write it as y is equal to something. So your answer therefore will be y is equals to 5 to the exponent x. Remember, folks, if you have written y is equals to 5 to the exponent x, you will not be penalized. You will have your full 2 marks because that's what they're asking you to do. So, in other words, if you can be able to have another way of figuring out how to write this, you can, and write it as y is equals to 5 to the exponent x, and then that will give you your 2 marks. Okay, and that's it. Okay, we are continuing with the question 4. So we are going to question 4.5. Remember, this is the question that we are talking about. So in question 4.5, they said, write down the equation of the asymptote of h. In other words, if they say the asymptote of h, they are taking that h and they say it's h of with x minus 3. Now the x minus 3 equation of asymptote with the h, it's just, we are in 4.5, so let's write that down. It's 4.5. The asymptote therefore will be y equals 0. It is y equals 0 because we are dealing with x minus 3 and it does not really have another asymptote than the one that is. Remember, we had written the equation of h in 4.4, which was the reflection of f in line y equals, so it was y, let's remind ourselves, it was y equals 5 to the power x. So there's no shift that has happened there. In other words, if we had to write, we'll say plus 0, but plus 0 is the same as when we have written nothing. That is why our asymptote, therefore, will be y equals 0. I guess that is clear and it is straightforward. In 4.6, they said we must calculate the coordinates of V. So 4.6, we are looking for the coordinates of V. If we look at it, the coordinates of V, it is at the intersection of the straight line y is equals to x and the hyperbola g of x. So the intersection means the two are equal. In other words, your y there will be equals to g of x. Remember, y is x equals to, the g of x is 2 divided by x minus 1 plus 1. And then we do the algebra to get to the solution. Remember, moving the 1, we subtract it in both sides. So we'll have x minus 1. And here we'll remain with 2 divided by x minus 1. And then we multiply both sides by x minus 1. So when you multiply both sides by x minus 1, we will now remain with x minus 1 times x minus 1 in a bracket equals 2. Remove the bracket, we'll have x squared minus x plus 1. And there's a minus 2. Okay, and from there, we do the simplification. When we simplify, we look at the like terms. So we have x squared minus 2x minus 1 equals 0. And then we factorize. When we factorize there, we'll have x, let me see. When we factorize there, we'll have x squared minus 2x minus 1. We will now have to use a formula, which is a quadratic formula. It is x equals to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So, folks, every time when you can factorize, you will have to use a formula, which is a quadratic formula. And in this case, that is a formula. Remember that your value of b, it is the one that is attached to x. And the number that is a coefficient of x squared is the value of a. And the one that has nothing to do with x, it is alone. It's going to be your constant, and that is c. So we're going to have a minus, which represents this one, and minus 2 plus or minus the square root of, we said b is minus 2, so it's going to be minus 2 squared minus 4, a is 1, and then c is minus 1. Okay, then we divide it by 2 times a 1, which is a. And then you can simplify this in the calculator, then they will give you a solution whereby it is 2 of them. It is giving you x being equals to 1 plus the square root of 2, or x will be equals to 1 minus the square root of 2. You can write in the decimal format or leave it like that. It will never have a problem. Now remember, we are looking for the coordinates of V. And one of the graph along that line or along that point V, it is y is equals to x line. That simply means that even our y value will be the same as our x value. So we're going to say also y is the same as them. So in other words, you're going to go further and say, and y is equals to 1 plus the square root of 2, or it is y equals to 1 minus the square root of 2. So you go back to your graph and you say, okay, where do I find a positive and where do I find a negative intersection? In first quadrant, I'm going to find both positive intersection. And in fourth quadrant, I'm going to find negative intersections. So it means that my coordinates of V, it is actually the positive one. So it's 1 plus the square root of 2 for x, and also the y is 1 plus the square root of 2. You can actually write this thing as decimal. There is no harm on that. And that is the solution to that question. Okay. I guess that is much clear and everyone can get it right. Okay. The last question is 4.7. So 4.7 is kind of another little bit of a trick, but with no much of the problem. Let's look at it. Determine the coordinates of T prime, the point which is symmetrical to T, about the point R. So another way they're saying, if you look at point T, there's point T, there's point R here is going to be at the middle. There's another point here that is symmetrical, for which when we fold this, they will all be on top of each other. Whatever point is there plus the point T. So that is the point we are looking for. Now, what did we say T was? We said point T was -1 and 0 in this point. And point R is our intersection of the asymptote, which is a 1 and a 1. So that's what we are looking at. We are at 1 and 1. Going to -1, how do we move from there to go there? That's how we actually direct. We count it until we reach our point T prime being a 3 and a 2, with just the movement from the given graph. From R to T and from R to whatever point. So the point that we are moving to the graph and to R must be the same that you're going to move to the point and then go back to the R, from R. Okay, thank you.